Question 4, it says particle P is moving on a straight line from a fixed point O, and the displacement function is given. So this is a variable acceleration question. So you got the displacement function given as 2t cube minus 12t square plus 18t. They want you to find the values of t for which p is instantaneously at rest. So for it to be instantaneously at rest, we must first find the velocity function. So velocity function would be ds by dt. Let's differentiate this. That's going to be 3 into 2 is 6t square minus 24t plus 18. So this is the velocity function. When it is at instantaneously at rest, obviously v should be 0. So we can say when instantaneously at rest should be v0. So 6t square minus 24t plus 18 equals 0. I can divide by 6, so t square minus 4t plus 3 equals 0. Factorize this, t minus 3, t minus 1 equals 0. So t equals 1 or t equals to 3. So those are the times, the values of t for which p is instantaneously at rest. So that will be the answer for part A. Part B says find the total distance traveled by p in the interval of 0 to 4. Right. So it says a particle is, the distance given from O is s meters. So we can say when t equals 0, if you substitute the value of t being 0 to s function, you will say that s is 0. So at the beginning, the particle was at point O. So since the particle is instantaneously at rest at two different points, probably it's changing the direction of motion. So it's better to find the displacement from O at t equals 1 and t equals 3. So let's substitute t equals 1 here. So s will be 2 times 1 cube minus 12 times 1 square plus 18 times 1. So that should be, let's say s1. That's 2. 18 minus 12 is 6 plus 2 is 8 meters. So at t equals 1, the particle is 8 meters away from the point O. Also, when t equals to 3, s3 equals to 2 times 3 cube, 12 times 3 square plus 18 times 3. Let's find that. So this should be 54 minus 108 plus 54, which will be 0. So at t equals 3, the particle has come back to the starting point. Also, when t equals 4, let's find that value. 2 times 4 cube, 12 times 4 square, and 18 times 4. So this should be 128. And this is 12 into 4 square is 192 plus 72. So 128 minus 192 plus 72 gives you once again 8 meters. Right, so here's the number line, here's 0. At t0, the particle was here at t equals to 0. When t equals to 1, the particle has traveled 8 meters to the right side because s1 is 8. So we can say s3 is 0 and s4 is again 8. So then at t equals to 3, it comes back to the starting point again. So it goes from, let's say this point is O, this point is A, goes from O to A and comes back A to O. and this is when t equals to 3. Again at t equals to 4, the particle has gone back 8 meters, right? So the total distance would be from 0 to t equals 1, that is s1, and also the distance it's traveled back from t equals 1 to t equals 3, let's call that one as 2, and then the distance it travels from t equals 3 to t equals 4, that's, let's call it as 3. So these are not the s3 s4 values you can see there. So it travels from o to a 8 meters, then comes back. So basically goes like this and comes back and again goes there. So this, each one is 8, so you can go upwards 8, again returning back 8, and again going back 8. So the total distance traveled should be 24 meters, right? That should be the final answer for part B. For part C, they say find the maximum speed, in this interval of 1 to 3. Right, when the speed is maximum, dv by dt should be 0. So let's take the velocity function first. We found the velocity function to be this one. So v is equal to 6t square minus 24t plus 18. So dv by dt function should be 12t minus 24. At maximum speed, we can say dv by dt is 0, which means 12t minus 24 is 0. So t should be 2. At t equals 2, the speed, we can take the velocity function, 6 times 2 square, 24 times 2 plus 18, that should be 24 minus 48 plus 18. So this should be minus 6. But since speed is not a vector, we can say maximum speed is 6 meters per second. So that is the final answer for part C.